going to do a practice problem or an example from the section 1.5 homework, just so everyone is really clear on how to approach these kind of problems. So this one says I have a golf ball and it says the height of the golf ball is given by or is equal to f of t equals this function. And then it tells us, it's telling us here really the input and the output. So it's saying where f of t represents the height in feet, and it's important to always use the units of measure when we're interpreting or contextually describing a problem. And then it says t is the number of seconds that have elapsed since the golf ball started going up. So in this case, I have function f where I input t in the parentheses and then I output, or it gives me, the height of the golf ball. All right. So part 1 says create an input-output table, and then it's telling us it wants t to span from -13 to 12. All right, and it wants us to start in column A, and that's where we're going to put our t values. So I'm just going to label these columns t, and I'm just going to write, this is my input. The input is always going to go in the first column, and I'm just going to add here that input is time elapsed in seconds. All right. And then you should know how to do some of these formatting tips that are in the earlier units. Let me just make this bigger for a second. So if I want to wrap this, I don't want this column to be this wide, and you see it extends out. I'm going to use this to wrap the text so it all ends up in one column. All right. And so then in column B, that's going to be my function f of t, and this is equal to -16 t squared plus 87t plus 7.6. And this represents the height of the golf ball. This is my output. So I input time and I output the height of the golf ball. All right, so let's wrap this text as well. And if I can make that a little bit bigger. Okay, and I'm going to make those go up at the top. All right, so there's my column headings. So let's go ahead and enter this function here. So it told me it wants my inputs to go from -13 to 12. So I'm going to start, my inputs are here, time -13. And to get these, instead of typing these all in, I would just tell it that I want it to step by 1. So I typed in -13 and -12. I'm going to highlight both of those, and then I'm going to wait till my cursor is a black plus sign, and I'm going to drag it down. I'm going to drag it down, and Excel is going to be smart enough that it's going to continue that pattern of just adding 1 for each step. And then I want to go to 11, 12, 13, or to 12, it told me. All right, so now I've done that. I have my inputs going from -13 to 12, meaning from -13 seconds all the way up to 12 seconds. That's what that really means. Let's enter our formula here for our function that's going to give us the height of the golf ball. We always write in Excel when we enter a function, we say that the cell is equal to, in this case, -16 times, and we're going to reference time. Time is in column A, A2, and we want that squared, raised to the second power. We don't want to put extra parentheses. Sometimes that can give us inaccurate results if we put too many parentheses and it changes order of operations. All right, plus 87 times t plus 7.6. And then we're going to hit enter. Now we can get this whole formula copied all the way down. If I bring my cursor down, you see the cursor changes the way it looks. All right, and each of them has sort of a different functionality. We want the cursor when it's a black plus sign. I'm going to double click, and now it has copied that formula that references column A all the way down. So when you're going to enter here in part A, it wants you to enter exactly what you would put into Excel, including the equal sign. So I want to enter this formula right up here. That's what I would enter into that box A with the equal sign and everything exactly as I would enter it in Excel. Okay. So then part B says the y-intercept is 0 blank. So whenever we have an ordered pair, the first entry is our input. The second one is our output. The y-intercept always happens where our x value is equal to 0. So all this wants us to do is to find what is my y value when my x value is 0. So I'm going to come down here, or when my input is 0. So when I come in my table here, I come down. Well, here's where my input is 0. When my input is 0, my output is 7.6, or meaning at time 0, the height of the golf ball is 7.6 feet high. Okay, because it told us the height is in feet. So I would just enter 7.6 here. This next question says the x-intercept on the left is, and the x-intercept on the right. Well, let's go ahead and graph this thing first, because let's see what this looks like. So if I insert, and I'm going to go here to scatter plot, and then I want to choose the smooth line graph here. So here is what this looks like. So what is this question really asking? The x-intercept is where the function goes through the x or crosses the x-axis. So you can see it crosses in two places. It crosses where it looks like, let me just see if I can draw here, right? It looks like it crosses right about here and right about here. So it crosses the x-axis in two places. So this question is saying, find where it crosses on the left. So the first one is talking about where does it cross on the left. The second one is asking where does it cross on the right. And whenever we have an x-intercept, we want to find the x value that goes with a y value of 0. An x-intercept always means that my y value is 0. So that's where I'm going to use solver. When I'm given the output of a function, I solve for the input. So how am I going to do that? Well, I see that there's two, right? I see that there's two x-intercepts. So if I want to start with the left one, I'm going to look in my table here, and I see that my output values are negative, 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 negative. Oh, here I'm at negative 95, and then I go up to positive 7.6. So what that really is telling me is that somewhere between negative 1 and 0, time negative 1 and 0, my function crosses the x-axis because it goes from negative 95 to 7.6. That's this value. I want to find the value in column B that's closest to 0. That would be 7.6. That's what I want to use solver on. All right, so I'm going to say data, and then I'm going to say solver. I want to set my objective. I want to set this cell to a value of 0, and I want to solve for the input that will give me an output of 0. I always want to unclick this box here, and then I want to solve. Okay, so a lot of times you're going to get this weird number here that is like, wait a minute, that doesn't look like 0, but this is a very small number, negative 2.55879. times 10 to the negative 7th. So that is scientific notation there. If I think this problem said that we want to round to 3 decimal places. All right. So if I do that, you can see that that rounds to 0. In fact, I'm gonna make this whole column have 3 decimal places because that's what this problem is asking. All right. So that's our first x-intercept. When my input is negative 0.86, 0.86, my output is 0. That's what I would put in this first box. Okay, that's my left intercept. Now let's find the right intercept. So again, I'm going to continue down my outputs. Positive 78, positive, positive. Now it's getting smaller, smaller, smaller. Okay, so somewhere between 5 and 6 seconds, the height of my ball goes from positive 42 feet to negative 46 feet. So somewhere in between here, it crosses the axis. I want to select the cell that is closer to 0, which would be 42.6. I'm going to do data, solver. And I always want to clear this cell out so it doesn't have old information. I want to make this cell equal 0, a value of 0. And then I want to change this input value because I want it to solve for what the time is that's going to result in a height of 0. Solve. Okay. So this tells me that at a time 5.523 seconds, the height of the ball is 0. Which, what does that mean? If the height is 0, it means the ball has hit the ground. All right, so I want you to always connect to what is the context of the problem. Right, so that's our two x-intercepts. So now this next part says at the time of launch, the golf ball started at a height of how many feet? At the time of launch means that no time is 0. That's what it's asking. Right before you launch the ball, what was the height of the ball? So when the height is 0, when time is 0, the height is 7.6 feet. All right, so you must be standing on some sort of platform before the golf ball is hit. So you can see 7.6 feet. And then it says the golf ball moved upward and reached a peak of how many feet after how many seconds? Well, let's look at the graph here. The ball is going up, up, up. Let's look at our table here. Okay, so time 0, I'm at 7.6 feet. The golf is traveling up. At 1 second, it's 78.6 feet. At 2 seconds, it's 117 feet. At 3 seconds, it's 124 feet. At 4, it's starting to drop. So somewhere around here, it hits a high. But I want you to go back here. In this problem, it told me that at 2.719 seconds, the ball hit a height of 125.866 feet. That's what it's looking for. Gave you this information here telling you the maximum point is at 2.71 and 125.866. So at 2.719 seconds, the height of the golf ball is 125 feet, 125.866 feet. Okay, 125.866, that's the height at 2.71 seconds. The object then fell downward until it hit the ground at how many seconds? Well, if the ball hit the ground, it means that its height is 0. That's this other intercept here. That's why we came up with the intercept. So at 5.523 seconds, the height of the ball is 0, meaning it hit the ground. That's what this question is asking. So at 5.523 seconds, the height of the ball is 0, or in other words, it hit the ground. Then it wants to know the real-world contextual domain for f of t. So meaning, what are the inputs? Now, in this function, we can see up here in our input-output table, we can put negative numbers into this function, right? And we can get an actual answer, theoretically or mathematically. But if we talk about contextually, we can't have hit the golf ball negative seconds. So we're not going to have anything less than 0, right? So we can start at 0 seconds and equal include 0 seconds, and then 1, 2, 3, 4, and then we really contextually, we can't have seconds beyond the time that the ball hits the ground again, because the ball can't go negative unless it went into a hole, but here it hit the ground at 5.523 seconds. And it asks you to write this in interval notation. So at time equals 0, meaning inclusive, meaning we have a bracket, and then the greatest time is at 5.523 seconds, and when it equals 5.523 seconds, the height of the ball is 0 feet. All right. So then let's take a look here. It said the real-world contextual range. The range goes with or refers to the outputs. This wants to know what is the real-world range or height of our golf ball. Okay, so in this case, the real-world range could be that it's 0 feet in the air all the way up to the maximum height up here, 125.866 feet.